Welcome to Chemistry with Dr. Z. I'm Dr. Z, and in this video, we're gonna talk about Group 1 elements. This is part of the specification for IGCSE chemistry and GCSE chemistry. So looking at the periodic table, we said that there are different groups. So we talked about group 0 elements, and now we're going to talk about group 1 element. Group 1 elements are the first group, the one on the far left of the periodic table. These group include lithium, sodium, potassium, rubidium, cesium, and francium. Hydrogen is not considered as one of the group 1 elements because it has a completely different properties. So the group 1 elements are called the alkali metals. And the alkali metals, they are all metals and they are soft and they have low density. Actually, the first elements in the group are less dense than water, so they will float on water because they are less dense. They have similar chemical properties because they have one electron in their outer shell. So we said that we can find out how many electrons are there in the outer shell of an element if we look at where in which group there are in the periodic table. So group 1 elements all have only one electrons in their outer shell. And because they have one electrons, they have similar chemical properties, meaning that they tend to react similar to each other. What they do is that they tend to lose that electrons because it's easier to lose one electron than gaining 7 electrons in order to reach the stable configuration of a complete or full outer shell. So they tend to lose that single electron to give +1 charged ions. So this is the main thing. So all of them can give +1 charged ions. And they form ionic compounds with nonmetals. So the main chemical properties of these that they form ionic compounds with nonmetals. So now let's talk about the reactivity trend for group 1 elements. As you go down the group, you're going to see a certain trend in their reactivity. So first of all, or in their properties, chemical properties or reactivity, they all have the same chemical property, but reactivity is different. So the reactivity will increase down the group. So if you look at it, so you have lithium and then sodium and then we have potassium, rubidium, and so on. So sodium is more reactive than lithium and potassium more reactive than sodium and so on. The reason behind this trend is that as you go down the group, the outer shell is more, the outer shell electron or the electron in the outer shell is more easily lost as the attraction between the positively charged nucleus and the outer shell electron decreases as it becomes further away from the nucleus. So as the electron is further away from the nucleus, the attraction between the electron and the positively charged nucleus will be less, so can be easily lost. This is why it's more reactive. Looking at the physical properties, the melting and boiling point. The melting and boiling point will increase down the group as well. The reason behind the increase in the melting and boiling point is also the same reason why we said that the increase in the melting and boiling points for the group 0 elements, because as you go down the number of electrons will increase. If the number of electrons increases, that means the intermolecular forces between the atom will increase, and that means we need more energy to separate these atoms. So going down the group, increase in the number of electrons, total number of electrons in an atom, which means an increase in the intermolecular forces and between the atoms and increase in the melting and boiling point. Of course, as we go down the group, the relative atomic mass will increase. So let's have a look at the different chemical reactions of the alkali metals. So the first reaction is the reaction with water. So they are very reactive metals and they react vigorously with water to produce hydrogen gas. You can see the hydrogen gas as effervescence or bubbles in your reacting vessels. And the also, in addition to hydrogen, they produce metal oxide, hydroxides. This is why they are called alkali metals because they tend to make alkaline solutions when they react with water. As we said, as we go down the group, reactivity increases. And if reactivity increases, that means the reaction will become more violent. And the reaction becomes more violent because it releases a lot of energy. And as it becomes more reactive, more energy is produced or more energy is given off. This is why this reaction becomes very violent as you go down as the reactivity increase. So let's have an example. So if we have sodium and you react sodium with water, then you're going to have sodium hydroxide and hydrogen. This reaction, of course, this equation is not balanced, and we can also, since we are writing equation, we should consider how to balance this equation. So let's look at the sodium first. Sodium has the same number on both sides, one sodium both sides. And then we look at the hydrogen. There is no hydrogen, two hydrogens here, and there are three atoms of hydrogen on the right-hand side of the equation. To balance this, we can add 2 next to the H2O and 2 next to the sodium hydroxide. In this case, you're going to have 4 hydrogens on the left hand side and 4 hydrogens on the right hand side because there are 2 hydrogens now for sodium hydroxide. If we look at oxygen, there are 2 oxygens here from 2OH and there are 2 oxygens here. But then again, we need to look again at the sodium. So there is only one sodium on the right, 2 sodiums on the left. So you need to add 2 next to the sodium. This is how we balance this equation. So now this equation is balanced. Moving on to a second reaction, which is reaction with oxygen. So they react with oxygen and they give metal oxides. The different metals in this group will give different types of oxides depending on the metal. So lithium, when it reacts with oxygen, it gives lithium oxide, Li2O. And sodium gives a mixture of 2 different oxides, which is sodium oxide and sodium peroxide, Na2O2. This is called sodium peroxide. Potassium as well, when reacts with oxygen, gives a mixture of 2 potassium oxide and potassium peroxide. So you should know the different oxides that are produced from each metal. And you should also try to balance your equation if you are asked to write the balanced equation for the reaction. The third reaction is reaction with halogen. So halogens, for example, chlorine, are one of the non-metals. They are in group 7 elements. And we said that the metals, group 1 elements, react with non-metals to form ionic compounds. So they also react with halogens vigorously when heated with halogens like chlorine, and they give metal chloride salts, which are white solids. The reactivity will increase down the group as well, and the reaction becomes more vigorous. So more vigorous reaction because of the increase in the reactivity. So let's have an example. Again, if we have sodium plus chlorine, that gives you sodium chloride. This is not balanced because there are two chlorine here and one here. So you need to add 2 next to the sodium chloride, which to balance it on the left hand side, you have to add 2 also next to the sodium. So this is the balanced equation for reaction between sodium and chlorine to give sodium chloride. You can apply this to any other metal from the series. So if they ask you about potassium, you can simply add potassium plus chlorine will give you potassium chloride, and so on.